Hello, good evening, all of you. Good
Good
evening, all
evening.
of you. My name is Parth Joshi. I'll be conducting the session for this course. Welcome all of you to this session. Let us wait for 1 or 2 minutes more to for more people to join, and then we'll get started. Good evening, all. Can you just confirm whether you are able to hear me and see my video?
Yes, sir.
Okay. Yeah. Sure. Thanks. Thanks. So maybe in a minute or so, we will just start in a minute. Welcome all. Good evening. I think we can get started now. So, yeah, so let me just start. Like, I'll just tell about myself. My name is Parth Joshi. I'm a PhD student in the Department of Mechanical Engineering at IIT Bombay. So, um, I am a recipient of the Prime Minister's Research Fellowship. And as a part of this fellowship, I got an opportunity to interact with you through this online session. And so I'll be conducting this online session every week in the Friday slot 7 to 9. And so in this session, basically, it's as it is called as a problem solving session. So it is mainly meant to address any questions that you may have related to the course content or anything uh, else that you want to ask. So do make use of this session. Uh, so so I will try to answer as much as I can. So I have been basically conducting this session since the last 2 years or so. And yeah, and about my experience, so I've this is my fourth year of my PhD, and I'm working in the area of electric and hybrid electric vehicles. So I'm basically focusing on the energy management part for these things. And prior to joining my PhD, I was working at a company named Eaton in Pune. So I was working for about 2.5 years, and before joining Eaton, so I did my master's MTech in engineering design, basically from the mechanical engineering department. So I graduated in the year 2018. So I have so I am an alumnus of IIT Bombay as well as a current student. And I did my graduation in mechanical engineering from BITS Pilani Goa campus. And after my graduation, I also worked at SKF Bearings, so in Bangalore and Pune for some time. And then I joined my master's course. So this was a brief introduction about myself. So I think so we can just start with a quick introduction of I think all of you. So I would also like to know what is your background, like are you an undergraduate student? Are you from and from which discipline? So can you just raise your hands? How many of you are doing your BE Tech? Okay, one, and what about the others? So Dalan, right? So you are, yeah. So you are doing your BTech. So you are doing your BTech in which discipline?
Sir, in college, I am in right now. I am in fourth year.
Fourth year of
So
mechanical engineering.
yes, sir.
Okay, yeah, sure, great. So nice to have you. So about the others, so how many of you are doing your masters? Any one of you are doing your masters? And about the and anyone who is like already working in industry or basically working. So Mr. Amit, so you are working, right? So you are working where exactly?
Sir, I am from mechanical engineering. I am working as a faculty member.
Okay,
I have done BTech as well as MTech.
okay,
The primary intention to join this course is to get refreshed about the concepts of mechanical vibration,
okay,
and I think this course will also help me to teach in a better way, sir.
okay, great, great. So which college are you teaching in, sir?
Sir, I am from Rajasthan.
Okay,
I teach in Polytechnic College,
okay,
the diploma engineering, sir.
I see. Okay, okay, great. Yeah, so it's nice to have you, sir. And
Okay.
others, uh, so can you just quickly tell me where are you from and like what exactly are you doing? So are you, yeah, so Mr. Prashant is also a faculty in Usmanabad, Maharashtra. Okay, and attended as FDP. So what is FDP? Faculty Development Program. Okay, so so you have been at IIT Bombay? No. Okay. 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 Fine. So the Faculty Development Program basically offers you to take some courses or something, is it? Yeah. Okay. 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 Good. So yeah. So welcome all of you. And So what else, like anyone else wants to share what is their motivation to join this course, and what are your and also please let me know what are your expectations from this session. So maybe so we can, as we go ahead, we can try to address those as well. So anyone wants to share what is their motivation to join this course and what are their expectations from this session?
Sir, I am doing an internship out of my college from in a company. So my college told me to enroll in this course through got insight about this, so they
Right.
can able to transfer grades through this course.
I see. Okay. Okay, great. Okay, so you are already working in a company, is it?
No,
Like
sir, it's a internship program.
internship.
So
Okay, fine. Okay, okay.
6 months I am away from college.
Right, right, right. Okay, yeah, good. So yeah, sure. So yeah, basically through this session we'll be first like if you can like always tell me whatever questions that you have related to the content for that week, and I'll try to answer that. So if you came across any problem that you are maybe not able to solve or something, like we can take it up in the session over here. And generally I also have picked up some problems which I'll try to like demonstrate how to solve them. So some typical problems that you would see in the like in the assignments that like the weekly assignments. So generally like my plan is to like demonstrate like how to solve those kind of examples. So we'll discuss and then solve the questions as we go along. So uh, and yeah, I'll also try to give a brief overview of what is the content for that particular week, so that it gives you some idea of like what is the content, and then uh, yeah, so that's about like how I plan to go about. So any suggestions, any particular expectations that you have?
Sir, if in any case I can't able to join on Fridays, so can I able to see the recordings? Is it available, or you have mandatorily have to join it on Fridays so that to get the
Yeah,
insights of the
so
lecture?
yeah, you can always like get the recording, so you will be able to get the recording definitely. And if you have any questions, like you can always like join. And if you have any questions, like if you are not able to join the sessions, you can always post your questions in the discussion forum for the course. So I'll also try to answer your questions if you have like later on in the discussion forum. So that is also possible. And yeah, and like regarding this, like I also have been using the software called MATLAB. So you can also use this like this is a very powerful tool. So I'll also try to introduce at some point of this course MATLAB, and like how you can use MATLAB to solve some problems in vibrations. Like we can take up some simple examples and how we can use MATLAB to solve those. So I think that may be useful to I think many of you, and I think some of you are, since some of you are like professors. So I think you can like if you are not familiar with MATLAB already, so I think that may be something like that may help you. Yeah. So yeah, so I think at some point of time also I'll try to introduce how we can use MATLAB for solving some simple problems in vibrations. So in like so in basically in any like engineering problem, so we are basically trying to solve some differential equations. So MATLAB has a lot of solvers to solve differential equations, so we can make use of those. And like also we can look at another open source alternative to MATLAB, which is either Octave or Scilab. So we can also look at that. So like because MATLAB is a commercial software which for which you need to get a license or something. Octave is something which is very similar to MATLAB, but it is like freely available. So you can use that like at least to get started with the basic things. Like you can definitely use these free and open source tools. So if you want to do any project or something, like these software tools are like very useful for that. So okay, yeah, anyone wants to say anything, any questions, comments before we begin?
Yes, sir, I have two questions from the week one lesson, sir.
Okay.
The the first question is that the sir is, illustrated that we can convert a given function, say exciting force, etc., into a harmonic function. The periodic function can be expressed as a harmonic function, sir.
Okay.
Sir has explained the method in detail also and derived the equations to find the value of the relevant questions, the
Okay.
constants. But my question is that what is the purpose of transforming a given periodic function into harmonic function? What actually we want to get achieved through that?
Yeah, okay. So what so I got your question. So I think so when we like so when we are considering like there is some force applied which is, let us say, something, some periodic force, and yeah, so we can decompose it into like some of different harmonic forces. So that basically helps us in simplifies our analysis, because like let us say if we model our system, so we have a model, let us say if we have a spring mass damper system, like, and we are applying a force, let us say, which is periodic but maybe not harmonic, but some periodic force, and if we know like what is the response of the system to a harmonic force, so that is generally easier to derive, and so we can use simple, so we can analytically solve for that case where what is the response of the system to a sinusoidal force or harmonic force. So then we can use the principle of superposition. So let us say if we break down the force, let us say there is a force F, and we break it down into, let us say, components F1, F2, something, and then try to decompose it into some. So let me just try to, I'll just try to explain it using yeah, let me just write it down. So yeah, just hold on a minute. Yeah. So are you able to see whatever I'm sharing on the screen?
Yes, definitely.
Yeah. So okay. So yeah, so let me just write down whatever I'm saying. So yeah, so let us imagine that yeah. So let's consider like there is a simple spring mass system, and so there is a spring with stiffness K, and a mass M is suspended through the spring from. So then if there is a force F that is applied, so if it is a periodic force, then, and if we use some kind of Fourier analysis to find out what are like express it as a sum of harmonic forces. So yeah, sorry about the bad writing. So it's like so it's not easy to write on a Jamboard. So basically, it's like, so I think you get, so what I'm basically trying to express the force as a summation of sinusoidal forces or harmonic forces. Now we know the response of this system to this kind of a harmonic force. Like let us say that response, we call it as some xk. We know how to derive that, let us say. Uh, then we can, let us say, so if there is a, so then we know basically what is the response to f1 sine omega 1 t, then some f2 sine omega 2 t. So so then we can add up, so this is, let us say, x1, then the other is x2. So then the total response would be the sum of these responses like x1, x2 and so on. So then that would greatly simplify our analysis, because we do not know directly how to derive the response to a certain general periodic force. So by decomposing the forces into harmonic ones, we can basically simplify our analysis in that way. So does that answer your question?
Yes, sir.
Okay. Anyone has any other question? Anyone else has any other question?
Sir, I have one more doubt in the same concept.
Okay.
Like there are two types of exciting force. One can be a periodic function type, or other can be harmonic type, sir. So
Okay.
what exactly both differ from each other? Is sine or cos functions are always harmonic function?
Right. Right. So, like the general, you can say sine or cos, or they are basically broadly classified as harmonic functions. So then, so basically, so those functions, like, sorry, yeah. So basically, sine or cos or whatever, like those are basically generally called as harmonic functions. But like a periodic function is like can be like a more general kind of function. So like if you can say like square wave or triangular wave or like those kind of waveforms, let us say, those are also periodic functions. But it is not like easy to write like one single equation to represent what is the write a closed form function for that. So generally we can write a general periodic function as a sum of these different sine or cos functions, and then like by that we can basically simplify our analysis like that. Is that Does that answer your question, sir?
Okay, sir.
Yeah. Okay. Okay, fine. So then anyone else has any other question? So I think some of you joined late, so I'll just for those people who joined late, I'll just quickly tell about myself. So I'm Parth Joshi. So I'm basically a PhD student at IIT Bombay, and I'll be conducting these problem solving sessions every week. So basically these sessions are meant to answer whatever questions that you may have related to the content of this course. And I also plan to share some examples, typical kind of problems that you would see in the weekly assignments. So we'll discuss how to solve those as we go along this course. So that's about that. And yeah, anyone wants to ask or say something? So I like just asked some of the other people who had joined earlier. So I think some of you joined later. So how many of you are BTech or MTech or PhD students? Like those who have joined among them? So none, right? So like others are like working somewhere. So those who joined later. Yeah. Yes.
Yeah, I am working at Tata Motors,
Tata Motors. Okay, great. Where in Tata Motors?
Lucknow location.
Lucknow. Okay. Okay. So which part of the like where exactly which division are you working in?
I am a suspension design engineer, so in R&D segment.
Okay. Okay, great.
Department.
Okay, great. So what is your background? So you are from mechanical engineering or
Yeah,
from
mechanical engineering. I've done BTech in mechanical engineering.
okay, okay. So and how many years have you been working in Tata Motors?
Uh, in Tata Motors, 1 year.
1 year. Okay, okay. Yeah, good. Welcome. Yeah, thanks for sharing. So I did my internship at Tata Motors when I was doing my undergraduate studies in BITS Pilani. So yeah, so but I was working in the Pune factory.
So actually, the R&D division in Pune it is totally supporting for design activity. So here.
I see.
Uh, for production and development of commercial vehicles. We are supporting that.
Okay, okay. So so your name is Deepti Ranjan, right?
Yeah, Dipti Ranjan.
Yeah. So yeah, welcome. So basically, so what is your motivation to join this course?
Okay, from last year I am working on suspension design. So as you know, like in suspension, vibration plays a main role. Like
Right.
that's our motive. So I want to learn from that perspective.
Okay, okay. Good. Yeah, thanks. Thanks for sharing. Sure. So I think then we can get started. So yeah, so I'll be basically sharing some examples like which are typical type of problems that you will see in the assignments. So I'll basically trying to demonstrate how you solve those kind of problems. So I have like put together some small like number of problems. So then we can like discuss those. And if you have any other questions of your own, so we can also discuss that and I'll try to answer those questions also. So let's get started. So let us start with solving the questions. So the first question is a harmonic motion is what? So the options are aperiodic, periodic, random, or none. So what would be the answer to this question? Yeah, so basically I would like this session to be as like interactive as possible. So please try to participate as much as you can. So it's like it would be good like if it's not good like if I'm just like I just go on speaking something and I'm just like like talking to a wall. So I would like if all of you would participate. Yeah, so right. So So the correct answer is yes, it is periodic motion. So we just discussed that. Yeah. So Deepti Ranjan, you were saying something?
No, sir.
Okay. Yeah. So let's move to the next question, which is like just related to that. So if there exists a non-zero number capital T such that f of t plus capital T is f of small t, then that function is said to be what? So any idea what what it is?
Sir, periodic.
Yes, it is periodic only. So that is the general definition of any periodic function, that if there is a number t. So what is that number capital T? What is that called? If let us say t represents small t represents time. Yeah,
Time period.
yeah, time period. So t is basically the time period. Okay, so let us move on to the next question. Yeah, and yeah, so I forgot about to mention about one thing. So yeah, so let us like just first quickly cover that. So I'll just quickly cover what is the content that we were we have for this week. So are you able to see my screen?
Yeah, busy.
Yeah.
Yes.
Yeah, sure. So, yeah, so basically the first week's content is about basically it deals with the fundamentals of vibrations. Where do we see, like, what are the common examples where we encounter vibrations? In some cases, vibrations are undesirable. In some cases, they are desirable. And then we like professor has discussed about harmonic motion, like how can we add two harmonic motions, and the phenomenon of beats has been discussed. Then professor has also discussed about Fourier series and harmonic analysis, how we can use this technique to resolve any periodic function into sum of harmonic functions. And the general procedure for vibration analysis has been discussed in details, and professor has also discussed about some numerical problems in his lectures. So I had put together a list of some videos, like just to motivate you, and just to discuss about how the study of vibrations is important. So many of you are already working in industry, so you are very well aware why we need to care about vibrations. So I had put together a list of some videos, so you can have a look at that. Maybe I can just play one or two videos for you. So, just let me know whether you are able to hear the audio. Vintage London. So, in this video, it's about helicopter ground resonance. So, any of you are already aware of this thing?
No.
So, are you able to hear the audio?
No, audio is not.
Fine, anyway, you can't. watched what, so I'll maybe just replay it for you. So anyone can just describe what exactly happened here?
Sir, I think as you told, due to resonance, the helicopter got crashed.
Okay, 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 fine. So you are partly correct. Yes. Anyone else wants to share what exactly is happening here?
Yeah, from the video, what it is showing, like the helicopter is grounded by some ropes and it is being tightened.
Yes,
And due to some rotating unbalanced force, it's the vibration starting. The vibrations are coming on the system.
correct, correct. Yes, yes. Yeah, exactly, exactly. So yeah, so there is basically a rotating unbalanced force, exactly. So which is, let us say, if there is some unbalance in the rotor blades, and then again that is, the you are tying the helicopter to the ground. So then, uh, so this phenomenon is called as ground resonance. So I'll not really talk about the phenomenon in detail. So it's like very complicated, but basically it occurs due to, like, it starts with the rotating unbalance, and then that causes something called as some self-excited vibrations, and those vibrations can, go on increasing to the extent that it actually damages the entire structure or whatever. So as you rightly pointed out, the important phenomenon is basically the resonance. So we'll see another example. So you might have already watched this earlier. So this is very famous. So the Tacoma Narrows Bridge. So you can see how the structure of the bridge is violently oscillating. So this happened in 1940. So that time, whatever technology that was available at that time. So it was a suspension bridge. Yeah. So basically, you see, like, the vibrations are so much that the structure is not able to withstand them, and eventually the bridge just collapsed. So that, like, may happen in some cases. So depending on, like, the so here the resonance was caused because of the like, powerful wind that was blowing, and then so that matched with the natural frequency of the structure, and that eventually led to the crash of that bridge. Another interesting example which I wanted to share, so I'll just play that also. So uh, so what we see is that uh, there are, like, some cases where vibration is induced because of the external environment. So then this is another interesting phenomenon which is called as where a fighter plane crashed because of pilot induced oscillations. So anyone wants to share what exactly is happening here? Yeah, anyone wants to share?
Uh, this is because of crosswind, but I don't not sure if how it is like implied to vibration causing this to
Ha,
crash.
so it's like some kind of oscillations which are, yes, one part is crosswinds, yes, you are right. And the pilot is trying to land, and there is a crosswind. So in order to compensate for that, the pilot has to do some controls through his stick. So this was as a result of, like, when this technology was like new. uh, there is a technology called fly by wire. So earlier you would have, let us say, some uh, direct cable based controls, like to operate the control surfaces of the aircraft, like the rudder and ailerons and flaps and all those controls basically. So you would use cable based direct mechanical controls. But then later on, the fly by wire concept was introduced, which is basically that you basically use some electronic controls to get what exactly the so you basically sense. So the driver will do some movement of the, let us say, stick, control stick, and then there will be some sensors which will capture what is the movement that the pilot has done, and then it will interpret using some controls, and there will be some actuators which will do the actual movement of the control surfaces.
Okay.
So for that, so there is a very important thing, like if the driver moves this stick forward or backward, or then, so if the actuator movement is sudden, and like there is a lot of input that is provided to the control surfaces, then the motion of the aircraft can go actually out of control. If the controls become very sensitive, like if I make, if the pilot makes a sudden movement of the stick, then if that is interpreted as something by the controller, and then again the pilot immediately tries to correct his action. So if it is leading to something which is undesired, then the pilot will again provide another input. So then that causes some oscillation, because the controls are responding like very fast, or as compared to the what the pilot can respond to. So then that may cause some pilot induced oscillations, what they call, and that actually led to the crash. So it's not exactly directly related to vibrations as such, but it's an interesting example of how like systems respond to different inputs, and how we need to design uh, like systems. So when we need to, first we need to understand in any system where vibrations are occurring and why they are occurring, and whether they are desirable or not desirable. And we basically we need to understand whether they are desirable or not. And if they are undesirable, we need to control them, to limit them. So we may not, we always be able to eliminate. So let us say in IC engines, like there is always a unbalanced force, which we cannot eliminate. So we can reduce, and by using some different like basically mounting the engine on some kind of vibration isolation mechanism, so by which the vibrations are not transferred to the chassis. Or so we need to basically first understand where vibrations are coming from, how we can control them, and if we cannot reduce them, how we can isolate them. Like, so these are some kind of things which are come up in industry. So so that's basically, so the purpose of showing these videos was basically to help you understand why is it important to study vibrations. So does that help? So can you raise your hand, like how many of you find it helpful or interesting?
Yeah, it's interesting. I mean, quite to understand like how you understand the system, like how vibration plays a role in a uh, like you have to before designing something or I mean before the designing get maturity, you have to study all the areas and how the system behaves so that you can figure out which type of vibrations and oscillations coming in the system.
Definitely, definitely. Yeah, exactly. So thanks for sharing your insights. So in also in like in your case, like since you are working in automotive industry, we also like in some cases there are some fault diagnosis studies. Sometimes there are undesirable vibrations which are coming up. So then we also need to study in some cases vibrations to understand if there is a fault lying in some machine. So let us say if there are some some kind of weird signals that are coming from the, let us say, gearbox of a car or something. So then if there is any damage inside that machine or something, so we can actually capture the vibration data from that and then try to understand from the data what exactly we can identify where the fault is based on the vibration signatures that are coming from that. So so that is how vibration analysis can help us in addressing some problems that may occur.
Exactly.
Sure. Yeah.
Thank you.
Thanks. Yeah, so we need to study the undesirable forces vibrations. Yeah, right. Sure. Thanks all for sharing your insights. So like I have basically put together some basic things like what is simple harmonic motion and beats. So I think if all of you are already familiar with the course content for this week, then we can just skip this part. So shall we skip this part, or shall we continue with this? Yeah, so I can skip. Yeah, sure. So I'll be sharing the slides so you can have a look at it later. So this list of videos will also be there in that, so you can also watch the other videos in this slide. So let's continue with our discussion on the assignment problems that we were working on. Yeah, so let's come to our questions. So when a vibrating system slides on a dry surface, what is the damping called? So any idea what is it called? So basically damping, Coulomb damping. Yeah, right. So damping is basically when we are trying to dissipate some of the energy. Um, so sometimes we are deliberately trying to dissipate energy. Let us say in case of uh, you know in like some cases, like let us say when you have you know s- like in a door hinge. So there are some kind of doors which you will come across where those door hinges have some kind of piston cylinder arrangement. So the door has its own spring action, like it will try to close on it by itself, but there is a piston cylinder to in order to control the motion of that. So that is a classic example of a damper which is used for a desirable purposes. For like if the damper is not there, then the door might slam, like just if it tries to goes out of controls. But so there damping will basically dissipate the energy, and so that the door will gradually close by the time it's almost closed. So that is an example of, let us say, viscous damping. So when the system is sliding on a wet surface, what is usually the kind of damping? So we discussed about dry surface, but what about if there is a wet surface?
Discuss.
Viscous, right? Yeah, so it will be viscous. Yes. So like if the film, like let us say if there is a film of fluid, so and if the fluid is very thin, then it may be actually a combination of Coulomb and viscous damping. So yeah, let's come to the next question. The displacement of a particle undergoing simple harmonic motion SHM follows this equation that is given here, where y is the displacement in centimeters and t is the time period. uh, T is the time. The maximum acceleration of the particle in centimeters per second square is what? So how do we solve this kind of a problem? Maximum acceleration is 1 by 2. Okay. So how did you come to that answer? A cos omega t plus phi, that is okay. So what is yeah. So here basically yeah. So you can compare it to the that like y is a so if y is a cos omega t plus phi, so here the omega as such is basically, so what would be omega? So it is pi by 6, and what is the maximum acceleration of the particle? So the velocity is basically the derivative. So y dot is minus a omega sine omega t plus phi, and y double dot will be omega t plus phi. So the the amplitude of the acceleration is minus a omega square. So the magnitude of maximum acceleration would be basically a omega square. So in this case a is half, and so a omega square will be basically pi square by 36. So basically pi square by 72. So that will be the amplitude of the acceleration. Make sense? Yeah, sorry about the writing. So it's like little bad. So shall we move to the next problem? Yeah, so the next problem is two springs having stiffness 18 Newton per mm and 12 Newton per mm. They are attached in series and a mass is suspended at the end of it. So the equivalent spring stiffness is what? So let us first draw the diagram for this. So this example as such may be simple. So I think most of you might be already knowing, what is the formula for, what is the equivalent spring stiffness. But hopefully, I am just trying to explain it again so that hopefully, all of you understand how it comes about. So when we are saying that two springs are in series, or so how do we go about deriving the equivalent spring stiffness? So to evaluate that, let us say there is some spring stiffness K equivalent. So that is basically the force per unit deflection delta. So now there are two springs here, and let us say the deflection of the spring 1 is delta 1 and the spring 2 is delta 2. So then what we have is that delta is basically delta 1 plus delta 2. So what is delta 1? So if the force, so because the springs are in series, the force that is transmitted through both the springs will be same. So the transmitted force is same. So delta 1 is basically force F by K1 and delta 2 is similarly F by K2. So when we put these two equations for delta 1 and delta 2 into the above equation, so we get that. So K equivalent is basically 1 upon 1 by K1 plus 1 by K2. So which is basically the expression K1 K2 upon K1 plus K2. So if we calculate this same thing for this example, what we get, what was the numerical value that we get? What is the answer that we get for this question?
7.2.
7.2. Okay, right. So the option A is correct. Yeah, so the next question is a harmonic motion is given by x of t is 20 cos 32 t plus pi by 2. So where t is in seconds and the phase angle is in radians. What will be the time period of the motion? So here again we use the same concept that like we write it as x cos and we compare the coefficients. So here a would be so a is 20 and omega is 32. And so the time period t would be 2 pi upon omega. So which is 2 pi by 32, which is pi by 16.
0.196.
Right. So let's come to the next question. The maximum displacement and amplitude of the foundation of a centrifugal pump were found to be 0.25 mm and zero point 0.4 g. So what is the operating speed of the pump in RPM? So how do we solve this problem? Yeah. So why would you like before we even yeah, you were saying something? So yeah, so like how do we solve this problem?
Sir, we will find omega first.
Okay, how do you find omega?
Sir, there is a formula, some
Okay,
omega square x.
right. Yeah, yeah, that is right. So basically the maximum acceleration is the amplitude into the omega square. So that the natural frequency of the oscillations would correspond to the speed of the rotation of the pump. So we can find it from that using that way. But before even we go into the problem, so why do you think there would be vibrations in a centrifugal pump that is like uh, in the found like why would there be vibrations in the foundation of the centrifugal pump? Any idea? As the problem says, looseness. Okay. Anything else?
Sir, there may be some uh, misalignment of the shaft with its original center.
Right. Exactly. Yeah, so it's very, if there is some rotating unbalance of some kind because of some, either due to some manufacturing defect, let us say, so there are many rotating parts inside, let us say, centrifugal pump. There is a impeller turbine or something like, and then if there is some small defect and which causes some mass unbalance or and then finally causes a dynamic unbalanced force, like so that basically those vibrations are transferred to the foundation on which the centrifugal pump may be mounted. So yeah, so you're right, that's how we basically get the uh, vibrations. Yeah. Yeah, so coming to our problem, so the maximum acceleration is basically is 0.4 g, or basically zero point 0.4 into 9.8, and our amplitude is 0.25 in millimeters. So basically this is omega square into x. So omega square would be 9.8 into zero point 0.4 divided by, so that would be basically 9.8 into, so omega will be, so what would be the answer for omegas?
125.21.
Yeah, so it, what is the unit here?
Radian per second.
Yeah, so this is in radians per second. So so in order to convert it into rpm, we need to multiply it by some conversion factor, so which is 60 upon 2 pi, or 30 by pi basically. So so it comes out to be around 1195 rpm. Right. So is that the same answer that you get? Okay, so I think then we can just move to the next question. So it's given that a body describes two motions, x1 and x2. So it is asked like what is the maximum and minimum amplitude of the combined motion and what is the frequency of beats. So how do we solve this problem? So how do you, any idea how do we solve this problem?
Sir, combined motion can be represented as a sum of the individual motion, sir.
Right. Okay. Okay. So what would be the maximum amplitude and minimum amplitude in this case when we combine them together? So let us say if x1 is a1 sine so what would be the maximum and minimum amplitudes? So maximum would be when the combined motion where both the signals are in phase. So when they are in phase, then the amplitudes will add up. So it will be basically a1 plus a2. So that will be the maximum, and it would be basically a1 minus a2. So when both the motions are out of phase, so then that will be the minimum amplitude. So the combined motion will be like minimum amplitude. And what is the frequency of beats? Yeah, so it's basically omega 2. So it's basically mod of omega 2 minus omega 1. So by 2 pi. So anyone wants to share like if where do we exactly like where what are some common examples where we may encounter uh, like beats, the phenomenon of beats? Anyone is aware of any examples? Where do we come across this phenomenon of beats? Anyone has any idea where we can like come across the phenomenon of beats?
No, I don't have any idea. Can you please explain like what is a beat frequency? I just yeah.
Okay, right. So like to explain what is the phenomenon of beats. So for that, okay. So to explain what is the phenomenon of beats, so what we can do is we can consider like two signals. Like let us say now here the more general example was where we combine two signals with unequal amplitude. But generally, to understand this phenomenon, it is easier to represent it in the form of same amplitude signals, and then we can derive analytically what it is. So let us say if one signal is x1 is a cos omega 1t and x2 is cos omega 2t. So let us right now for now let us neglect the phase difference part. So we can account for that also, but let us say like for simplicity we just add up these two. So if we add these two, it will be basically sum of two cosine functions. So there is a formula for the sum of two cosine functions, right? So anyone knows what is the formula? So when we add these two, what would be the result? So it will
Cos
be, yeah, yes, go ahead.
uh, cos omega 1t into cos omega 2t minus sin omega t 1t and sin omega 2t.
No, I think that's not exactly what I meant. So the it would be basically cos of omega 1 plus omega 2 by 2 into cos of so 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 basically this represents two sine waves multiplied to each other, or cosine functions multiplied with each other. So one has the frequency omega 1 plus omega 2 by 2, so which has a frequency higher, and the other is basically the difference between omega 1 minus omega 2, which is a lower frequency. So it's a combination of two frequencies. One is faster, the other is slower. So like if x1 is something like this, and x2 is something like, let us say something like this, then the resultant would be something which is like, so like this. So it if you construct an envelope. So the amplitude will increase for some time, and then again it will decrease and increase, keep on increase and decreasing. So that, like, this is the outer envelope, is basically the slower sine wave, and the inner one is the faster one. So it's basically, so the frequency of beats is the frequency with which the this amplitude goes on decreasing and increasing, decreasing and increasing. So that's the outer envelope part, which is the slower sine wave. So this amplitude, so when these frequencies are very close, then the omega 1 plus omega 2 will be high and omega 1 minus omega 2 will be small. So then you can clearly distinguish between these two patterns, like the the amplitude will initially increase for some time and then again it will go down. So the frequency of omega 1 minus omega 2 becomes very slow. So where do you think you can encounter this physically? Anyone has any idea? So let me give you a hint. It's related to music.
Guitar.
Yeah, but where, what exactly in case of guitar, let us say? It's basically need not be specific to any instrument as such. Like,
Uh, is this is using in noise cancellation kind of thing?
uh, maybe I do not know. I'm not exactly aware.
No, I'm just guessing like so, as you were saying, like imposing two frequencies.
Yeah. Uh, so regarding noise cancellation, I am not exactly aware, but what I think is that when you say noise cancellation, we know what is the general frequency which is going to be the noise. So then we use some filtering techniques to remove that from the audio signal. So that is generally what I understand by noise cancellation. So I do not know exactly, but I think that may be. Yeah, with respect, now coming to the phenomenon of beats. So if you have come across, when you tune some musical instrument, so what you generally do is, uh, so you have a certain reference audio signal of some kind, like let us say if you are tuning a guitar or any other musical instrument for that matter. So you generally need, you take a reference audio signal, you so keep playing that, and then you basically keep playing the, let us say, string or whatever, and then try to eventually, when you in a guitar you tighten the knob or loosen it depending on whether you want to increase or decrease the frequency, and you basically try to match it with the whatever reference audio signal that you are tuning to it. So when you are tuning, so you can actually, when the frequency of the string of the guitar, let us say, and the reference that you are, let us say, playing some constant reference, so when they um, you know come very close to each other, then you can actually hear this sound intensity. It will become like the sound that is produced, you can actually hear that, the sound intensity will initially go up, it will go down and again go up and go down. So you can actually hear that in case of tuning musical instruments. And once the frequency becomes like very close to the reference frequency, then you actually hear resonance. So then suddenly the sound intensity will actually go up and you will hear a loud sound. So then that is the time when the frequency of them two will match, almost match, or like, or perfectly match. So that is, so that's what, that's the example of where you come across beats. So
Sir, I have a question regarding this x1 and x2 function.
yeah,
Are these both waves coming from the same source? That means there is the same source, but it is producing two types of waves with slight different in their frequency, or they are two distinct sources running at the different frequencies, sir.
yeah, the source may be same or different, but it's basically two different functions or two different signals, or like they are interacting. So they are at two different frequencies, but they are interacting. So there is some interference, what is called, like, so there is a, at certain points of time, there is a constructive interference. And so you might have heard about this phenomenon. So what is constructive and destructive interference, so you might be aware, right? So this happens in
Yes, sir.
all, like it can occur in either mechanical vibrations or optics or anything. So like if you have, like, let us say two sine waves like here, and let us say I have a slower sine wave like this. So so here, let us say this starting phase is same, but when we try to combine them together, the amplitudes, so we when we add up, so here the amplitude will be positive, and here, like, it's now here the amplitude is negative for this, but it's positive for this. So the net amplitude will be something like, it will go up, and then eventually, like, reach zero somewhere later on, and then it will keep be negative somewhere, and then again go up. So at the places where it reaches its highest positive value, so those are the places where you will see maximum amplitude. So whenever two waves interact, so there is uh, you know constructive interference, so that is the place where you see the maximum amplitude, and destructive interference, where you will see zero amplitude at this, they will exactly cancel each other, or like that. So, and again, when the two signals are, like, let us say both are negative, so then you will see the maximum negative value in that sense. So it's constructive interference, but in the other direction. So in that sense, so the source of the waves may be same or different, but it's basically two different waves interacting in some way or the other. Like, okay, so another example that we can, like, think about, like, is like tuning forks. Like if you have two different tuning forks which have similar frequencies, um, like, but they are, like, not exactly equal but similar, and if you strike both of them and see how the sound intensity varies, then you can also similarly hear this phenomenon of beats. So why am I discussing the thing about sound? So it's like similar, uh, kind of, like the concept is similar, but you can actually physically come across this. So yeah, so the next question, uh, so before we come to the next question, anyone has any questions, comments, or anything? So if you have any question, please do stop me at any point of time. So it's given that there is a shaft which has a internal and external radius, so it's given. So we need to find out what is the torsional stiffness of the shaft. So what is the fundamental equation for torsion? So let us say there is a torque tau. So if there is a torque tau and the moment of inertia of the shaft, let us say, is J. G is the basically the modulus of rigidity, G, and L is the length of the shaft, and theta is the angle of twist. So, so what is the definition of the torsional stiffness K? T, let us say, it is torque per unit twist. So, which is G into J by L. So here we are given, or G already is given, L is also given. What we need to basically find out is J. So, so for that, how do we find out the value of J in this case? So we have a hollow shaft. Let us say it has some external radius R1 and internal radius is, let us say, R2. How do we find out J?
So there is a direct formula given in the book, sir, for the hollow shafts.
Yeah, fine. So what is that formula?
Pi by 32 d4 minus d4.
Pi by 32. Yes, pi by 32.
Uh, and d raised to power 4 minus d raised to power 4. The outer and inner diameters.
Yeah. So it's basically D1, D2 or whatever. So D1 is basically twice R1 and D2 is twice R2, right? So you're right. Yeah. So that's the yeah equation for J. So yeah, that's it. So like basically you just need to substitute the respective values and calculate. So anyone has tried to calculate what would be the value here? So anyone has tried to calculate what is the value? So I'm just trying to use Microsoft Excel to calculate this same thing. So it's G into pi So it comes out to be 125 125246. So
G something.
yeah, so it's basically same as option D, 125.25 kilonewton meter per radian. So everyone got the same answer? Yeah, okay. So yeah, if you don't have a calculator or something, like you can always use these tools like Excel or MATLAB or whatever. Like you can, just quickly use them to calculate things. Yeah. So yeah, so this is an interesting example. So the resultant displacement of three harmonic motions. So by looking at the the like vibrations, the motions that we have been given, even before like doing anything, what do you think would be the resultant displacement just by looking at the what is the motion? Any idea?
Sir, all three have same frequency.
Yes, all three have same frequency, and amplitude is also same. What is different is the phase difference, right? So any idea what, like, we can do calculations, like we can just, like, add up x1, x2, x3, like, and then use trigonometry and all that thing to derive what is the resultant displacement, etc. But physically, like, if you want to just quickly, without doing any calculation, if you want to find out what it may be, any idea? If not, so I'll just give you a hint. So any harmonic motion can be represented as a projection of circular motion of a, like, particle moving at a constant angular velocity. So we can use that idea here and apply it here. So now with that hint, anyone has any idea, like, how do we apply that? So if there is a circle of radius a, let us say, yeah, so let us say this is a circle of radius a. So if this angle, we call it as omega t, then the projection on the horizontal axis will be cos omega t. So this will be basically cos omega t, and this would be sin omega t. So into a basically. So it's a cos omega t. So it's the radius is a. So it will be, so the horizontal one would be a cos omega t, and the vertical will be a sin omega t. So so when the particle moves along the circle with a angular velocity omega, this projection on the vertical axis is a sin omega t. Now if we want to represent this thing, which is a sin omega to omega t plus phi, so how do we do that? So let us say this is the particle p1, let us say, which corresponds to the x1. Now if we want to represent the particle p2 on the circle, so it will be somewhere here, where this angle between these two radii will be 2 pi by, corresponding to 2 pi by 3 or 120 degrees basically. And similarly, this particle p2, which corresponds to the signal x3, so for, like, whatever, so if we project the motion of the particle p2 on the vertical axis, it will be same as a sin omega t plus 2 pi by 3, because the angle between this p1 and p2 is always 2 pi by 3. And similarly, if we consider a third particle which is further 2 pi by 3 away from, at an angle of 2 pi by 3 with this radius corresponding to the particle p2, so this is, let us say, p3. So this will be at an angle of 4 pi by 3 with respect to this particle P1. So if we want to align this particle P3 with P1, we have to again go further 2 pi by 3 to complete the whole circle. So it will be, so all these three particles are always 120-degree apart. So by that, if you get like, now with this, what do you think will be the resultant displacement of the three particles together? Uh, what do you think would be the resultant in this case now? See, considering that all are 120-degree apart, any idea?
So 0,
Yes, it will be 0. Exactly. Why do you think so?
because sir, all three particles are counterbalancing each other. They are
Yeah,
equally
exactly.
spaced with respect to each other.
Yes, exactly. Right. Exactly. So the symmetry of the problem is such that all the particles will move always with respect to like 120 degrees apart with each other. So it's like if you add three vectors which are 120-degree apart, the resultant will actually be 0. Yeah. So yeah, the resultant, like the vectors should be of obviously the same um, magnitude. So yeah, so that's right. Now we can also confirm this by using trigonometry. What is like a sine omega t is already, that is fine, but like a sine omega t plus 2 pi by 3. So what is sine some alpha plus beta? So it is, so x1 is given, so like a sine omega t, so it will be a sine omega t cos 2 pi by 3 oh sorry. Similarly x3 we can write it as a sine omega t cos 4 pi by 3 plus a cos omega t into sine 4 pi by 3. Yeah, sorry about the bad handwriting. So now what we observe is that, so what do we observe when we add these things together? So what is the value of cos 2 pi by 3? So it's basically cos of pi minus pi by 3, which is
Minus half.
minus half. Yeah. So it's minus half basically. So it's minus half. And sine 2 pi by 3 is what? Root 3 by 2.
Half.
Sine 2 pi by 3 is root 3 by 2. And similarly, cos 4 pi by 3 will be again minus half into minus half. Third quadrant, cos is negative, and both and sine is also negative. So it will be basically a cos omega t into again minus root 3 by 2. So now if we, just by inspection, if we can see that a cos omega t into plus root 3 by 2, and there is a term in x3, a cos omega t into minus root 3 by 2. So when we add up them, those two terms will cancel. Then a sin omega t into minus half, the terms in x2 and x3 will add up to, like, minus half plus minus half is minus 1. So it will be x2 plus x3 will become minus a sin omega t, and x1 plus x2 plus x3 together will again become a sin omega t minus a sin omega t, which is 0. So I think, hopefully, I think you understand how, trigonometry will again confirms that, right? So do you find this, does this make sense? Yeah, sure. So we have like about 5 minutes or so left, 5-6 minutes. So maybe we can just do one more problem. Yeah, a cantilever beam which is made of an alloy with Young's modulus 72 gigapascal. It is loaded transversely at its free end. So the length of beam is given, and the beam again has an annular cross section. Inner and outer diameters are again given. What is the stiffness of this beam? So let us first draw the diagram. So there is a transverse load F, let us say, and let us say the cantilever has a length L. Then how do we define stiffness in this case?
Sir, F by delta.
Yeah, and what would be delta in this case?
Sir, there is a formula for finding the delta for a cantilever beam when it
Yeah,
is loaded transversely at the free end, sir.
right. So, do you recall that formula? Yeah. So it's basically FL cube by 3EI. So I is the moment of inertia of the cross section. So the stiffness K would be F by delta, which is F upon which is basically 3EI by L cube. So E is given already, which is 72 gigapascal. L, the length is given. What our job is to find I. So it's given that it has an annular cross section. So inner and outer diameters are again given. So let us say DO is the outer diameter and DI is the inner diameter. So then we can write I is so now it is 64 pi d raised to 4 by, so why 64, any idea? So it is pi d outer minus d inner raised to 4 by 64 because we are looking at the moment of inertia in the plane of the cross section and along the axis of symmetry. So and then using the perpendicular axis of like perpendicular axis, we can find out this moment of inertia along like two perpendicular axes, and then that added together will give us the polar moment of inertia. So which is the moment that we use in torsion, and whereas in bending we use it along the plane. So yeah, that was the expression for this moment of inertia. And yeah, so I think someone tried to calculate. Yeah, so I is 2.99. Okay, meter to the power 4. Okay, yeah, so we can just try to calculate that. So E is basically 72 gigapascal. Outer diameter is 0.12 and the inner is 0.11 meters. The length is 0.75 meters. And yeah, so that's it. So basically we are calculating 3 into, yeah, so let us first calculate I. So it is pi the torsional stiffness will be 3 into A into, so it will be 1531840 something. So that's the value that I am getting. So that's how like we can calculate the the bending stiffness. So like I have some other problems also. So I'll be sharing this uh, sheet of problems with you. So you can go through them, and if you have any questions, so you can ask me. Like you can ask it either in the discussions forum, or maybe you can ask it in the next problem solving session. So I think we can stop here for today. So so can you just give me a quick feedback? How did you find today's session? So any did it? Yeah. Okay. Yeah. Sure. Thanks. So like hopefully it was useful for all of you, and so yeah. So let's continue discussing, and I'll see you in the next week. So in the next week I'll be actually traveling. So the session for the next week will be on 6th of August. Yeah. So yeah, so I think the NPTEL team will communicate that to you. So yeah, so let us meet in the next problem solving session. So thanks all for joining. Yeah, thank you. Good night. Thank you. Thank you for your feedback. Thank you.
Thank you, sir. Good night.
Yeah, thank you. Good night.